Okay, good evening. So today we will see the final part in linear regression with Scikit-learn and visualization with Seaborn. So today is the main interesting topic. So we will be using Scikit-learn, the machine learning library to uh, build our simple machine learning model to predict, depending on how much budget the movie is, how much revenue it might get. So yeah, let's go. First, let's start with linear regression plots. So yeah, we can do the analysis. So with two ways, let's see one by one. So let's plot regression plot. So it's like just a bubble chart, but we will have one regression line which will be drawn across that. So again, the same thing. So we will be plotting only using old films uh, data frames. So yesterday, if we have remembered, so we have created two new data frames, old films and new films. Now, now we're plotting, right? So this is our linear regression line. So here, depending on the graph, and we have to get the slope and intercept, and then we will be predicting that. So let's go back. So So the same thing, we have used matplotlib library, and then we have just used style access with a white grid. Yesterday we have already seen. Now, now we will be modifying a little bit. So using white grid, and now if you see, it is actually very visible. So yeah, this is a simple without using any matplotlib layer. So here we are using matplotlib layer. We are giving the settings. So, but there are very data points. For example, here this is nothing but Cleopatra film where we already seen that. So, so the lower budgets is having multiple higher revenues also before in the old data frame. So yeah. So what we identified is, so here the first thing we have Cleopatra film is having highest budget, and many lower budget films having more money because the x-axis is the budget and the y-axis is the worldwide gross. So yeah, the relation is not very correct because there are multiple our data points which is outside, not exactly near to the line. So this generally this data is not capturing our relationship with production and worldwide gross. So now let's check for the same for newer films. So yeah, if I just go back, so using the same again as for new films. So let's put on chart on dark grid, set the labels, accesses, limits on the accesses. So generally we won't be showing into value, label the axis and provide hexacolors. Older films. So let's see. So the same thing, we are just changing grid and we are using a different color, hexacolors, and here we are using a different color. So the most dots are dark blue and the orange line we are just giving for the linear regression line we are giving orange. here the scheme scatter the line, how much width it should be. So yeah, alpha. So here, if we don't set the limits, it might go into negative limits also. Or let's I will be seeing about both. So now we plot this. If you see here, there are many data points, and it is actually our linear regression line. The fit is correct actually. Like so, there are very less points which is outside the area of this plot. You see, so I think this is avatar, and this is having different. Only maximum there are 4 to 5. But if we see here, it is many of them are not in line with the this thing. And if we just remove this both, and if I run this, let me check how it behaves. So generally it is going below, but uh, since it is showing only 0, 0 or data points, so yeah, so just give it again. So the limits we will be setting it so that it exactly starts at 0, 0 and 0, 0 like that. Okay. So if I just remove it again, so why I'm doing so I will be it is not plotting negative, but generally it is actually starting at 0 and it is starting at 0. So generally it goes into a negative value. But our to avoid that, only we should define our limits well. So the axis doesn't show the negative values. Hexacodes. So these are the hexacodes we have provided, hexacolor codes. So now how we interpret the chart. So this is thing. So here we are getting much better fit. So maximum of our data points is across our whatever we draw the linear regression line. So it is actually the fit. So if I just go back to our chart, so yeah, so 1.5 million, 150 million, 1.5 100 is like $150 million is approximately make $0.5 billion. So it is like $500 billion if you just take this and this one. So as per this, so the data point is 0.5. So again, so machine learning is nothing but depending on our old previous data, it actually predicts the future data also. So it's, for example, depending on this data. So generally, what's happening here is, so for a $150 budget, we should get at least $500 million revenue by our regression line. pretty confident there doesn't need seems to be. So, but is it correct? So, is the model correct? How much uh, for $1 increment, how much revenue we will be getting? So, for that, we need to go into the main regression model, the scikit-learn linear regression model. So here univariate regression. So univariate is nothing but we will be using only a single variable, single explanatory variables. So explanatory variables. So this is we are using only our movie budget variable, and we are predicting revenue. So here theta 0 and theta 1 are the pointers. So depending on this formula, we will be estimating our budget. So generally, there will be multivariate and univariate. So and bivariate also. So depending on our factors, other factors, our regression model will be or depending on more factors. And again, this should not be given very huge vectors. It again leads to very computational costs, and that should not be done. So we have to very careful when we are building our models, machine learning models. Here we are building a very simple model, just using our data. We are depending building an linear regression model. So linear regression model is again nothing but in simple terms what we have provided. So it's like, so if you want to buy something, for example, if you want to buy a mobile phone, so you are saving some amount of data or some amount of money every time, like every month. So before also you have done this. For example, let's take an iPhone. So every year the new iPhone will be released, right? So depending on last year how many months you have saved, how much savings you have saved, accordingly how much uh, how much this year also you have to say how much months you need to say. That's a linear regression. So depending on our previous data, so for example you have saved nearly for 5 months you have saved around every month 20,000. So for in 5 months you will get 1 lakh. So similarly for the next iPhone model, for example, next iPhone model is just for example, if it is like 1,20,000. So here in this case, either you need to increase our savings or you need to increase a month. So for example, so for 1,20,000, how much months you need to save? It is like 6 months you need to save 20,000. So that's exactly the machine learning will tell us. The linear regression model will tell us. So, but it's a simple example, but it's having multiple factors also. Let's dive into that. So, so this is actually the estimated revenue. So y-axis intercept, and theta 0 is y-axis intercept, and theta 1 is the slope. The slope is like uh, for every $1 increment, how much revenue is estimated. That's exactly we will be doing. So, so the linear, so the lines intercept. So again, if you are looking at this formula, it is again seems to some linear regression y equal to some a plus or 5 plus 2x, something like that, right? Linear regression expression. So linear algebra expression. It's So machine learning is again dependent on mathematics, mainly whatever you take, all the algorithms, whatever you go from here, the data science, machine learning, deep learning, everything depends on mathematics only. So it is good to know the basic mathematics, linear algebra, how to solve what is the slope and how to intercept, like what is intercept. So all this. So so you don't need to calculate this because we will be using our models to calculate depending on our data. But it is good to know. For example, the line intercept values allows how much revenue a movie would make if the budget is zero. So it's like y-axis tell us. So at zero, like if the budget x-axis, if it is zero, so then y-axis, the intercept how much it is. It should tell us. So the slope, the extra revenue. So it is the slope. So if I just uh, point a triangle, so this is the slope. So you can get it by using uh, height like x square plus uh, for example, this is y, this is x, and this is y, and this is z. Pythagoras theorem. So z square equal to x square plus y square, something. So I just forgot the formula, but yeah, something like that. You have to, depending on the pointers, you have to calculate. But you don't know what to do every calculation manually. So that's where our scikit-learn library will come in place. So if I just open our scikit-learn library, so yeah, so there are multiple algorithms we can use. So as of now, we are using very simple algorithm. It is just a linear regression algorithm. But here, if you see here, applications regression predict a continuous valued attribution with an object. So it's like drug response or stock prices. So here there are multiple algorithms. So Bayesian, ridge regression, like last logistic, linear models. Yeah. So let's start. So first what we need to do, we need to import a scikit-learn library, and from that scikit-learn library, we need to import our model, linear regression. So we already done this at the starting of uh, our notebook import statements. If you go there, you will be seeing this link. Now what we will be doing, let's go back to our. So here we are creating a regression object. So it's like if you remember, so we are creating, this is the class to create linear regression is the class name. So we are creating a regression object using this class name. So now we will be using this object of this class. So now what we are doing, we are creating a two variables, like using data frame a new, and we are just taking only production budget column on x-axis. On y-axis, we are taking only worldwide gross. So we are creating two new variables. So yeah, because why we are doing this, why we are creating a new data frame. So because the linear regression don't take a panda series, that's why we are creating a single dimension pandas data frame. So if we give it, it won't work. So that's why we created x and y. And now on our object, we are calling fit method. So we are passing fit x and y. Let's create. Now to access what is the y-intercept. So here directly we can call on regression. We call intercept underscore attribute. We are getting some minus 8678. Even next one, now we are getting the theta 0 we got now coefficient. So we are getting coefficient as $3. So here just attributes of linear regression object what are we created. So don't worry because there is underscore is just developers cycle developers chosen for that attributes. So here y-intercept y, it is actually what it meant to say. So if a movie budget is $0, then the estimated movie revenue is minus $8.65 million. Actually, this is very unrealistic, right? But why our model tells that is that we are specifying what model should be at our time. Because we are just plotting it and we are just trying a single like linear regression line. So that's why it is actually yeah. So that's why we are just going to say. So if you draw a line using our data, so generally, if you just extend, so as of now, I said right without so the y-intercept, so on our x-axis, so if I just extend our linear regression line to backwards, so let me just again go back, for example. So here, if I just don't give the limits, for example, if I just move this linear regression line, for example, if I draw from here, something like here, even and that also will work, right? The linear regression line. So whenever there is a zero budget, so it's like if I just point this out, so it will goes into negative straight line, like because the y-axis is starting here, but if I just extend my line, like for example from here, if I just scroll to here, I can't. Okay, the orange line, if I just extend from here, it actually goes to negative, like some 0. From 0.8 or $0.08 billion, so which is nearly $86 million. So that's what I am saying. So we have to give our access accordingly so that we don't get any negative values. So that's what this y-intercept bit is about. When our x-axis is 0, uh, whenever x-axis is 0, so it is like whenever we extend the line backwards, it is going to some giving negative intercept. So as of now, if I just again show you this, so here this intercept is actually we are giving it 0, comma 0 only because we are starting at that. But if you don't give the limits, so it whenever it the y-intercept, so it is again everything is linear algebra. So the y-intercept whenever x-axis is 0, what is the y-axis value? So that's the y-intercept, and the slope I already told you that it's mainly straight line. So so this is one of the backdrop of this. So backdrop of this linear regression model. So it it might not be fit for kind of this kind of scenarios. To budget, we have to be careful about interpreting a very simple model too literally. Yeah. So look more accurate on the chart where we have the most data points rather than the extreme left or extreme right. Yeah, exactly. So depending on the chart, if we just take, so then the y-intercept will be actually 0 rather than the extreme left or right. Because we can't have negative revenue, right, or a negative budget. So there won't be there can be chances, but generally the revenue will be the least. It will be 0 only. It won't be any uh, negative. So even the negative budget, there is no concept of a negative budget. So yeah, this is very carefully interpreting our simple model to literally that. Because we are taking only one estimate, like one exploratory parameter, the budget, but go, uh, in more there can be multiple models. So for example, if you see here, this is y-intercept and whatever we have got it. So the coefficients, so the W0 is intercept and the coefficient. So it can be a multiple coefficients will be there, like multiple parameters also will be there. So coefficients can invest the residual sum of squares root. So these are different models. So you should be going and you have to just check for that. So classification model and yeah. So it's a very good starting library, Scikit-learn, to implement any machine learning model. So now, yeah, the slope tells us for every extra $1 in the budget, movie revenue increases by $3.1. So that's what we have got it right. The higher our estimated revenue. Yeah. So that's what right for every budget. So we have increase in revenue and even the increase in budgets also it got increased in every year. So this is already we have plotted three-dimensional plot like x-axis year, y-axis budget, and the hue and size is worldwide graphs. Now, let's find out how our model is exactly fitting. Like, is it explains our variance? So, how much percent of variance it is explaining? So, this is called R squared metric. So, you can just call R square on that. Once we are done, now, so if I just call this, so we are having around 0.55, like it's like 55.7%, like around 56.56% variance in the movie revenue. Yeah, because we're using only one explanatory model, generally it's like above 50% is very good. Our model explains around, so it is able to predict at least 56% of times correctly. Or how, like whenever you, uh, I meant to say, how much budget, how much revenue you will get. So the model is like depending on whatever the data we have. So that's the model we have built. So yeah, like 56% is a very good number. So, but as of now, we are using one example, but their real world will be well super complex. As of now, I have shown you. There will be multiple explanator variables. You need to take care, and depending on different kind of data, you need to actually do all that. Yeah. So it's actually a pretty decent model what I have built. Actually, that's a pretty decent data we have. So that's why we have built very good model. So let's see the same using new films data. So how our old films data will behave? Let's see. So this challenge. So it's like again and the same thing. So we will be using old films data. So again we will be creating x and y variables using old films. So the same. So here the coefficient is 1.67. So and the intercept is something like 2.8 $2.28 million, and the R square is very, it's like 0.02. So it is a very weak model because what's happened, yeah, only 3%, so 0.029. How poorly our data points aligned, yeah, because the data is aligned very our data points is not exactly correct because it is out of in nowhere near the our renal regression line. But if you just take our new data, it is actually very near. Every data point is plotted near to our line. So using old data, we are not exactly. I meant to say we are. The model is very a bad fit actually. It's like so because the R square is very low, so it's like only 3% of the time it will predict how much for how much budget, how much revenue you will get. So now the final challenge. So it's like so how to estimate. So the same thing, right? So now let's estimate our model, like how much, for example, if there is a $350 budget, how much revenue we can get. So again, the revenue, we are using this formula. So here we got theta, the intercept is 22 something, $28 million. So $2.28 million plus. Here our coefficient is 1.6413 and we are multiplying with $350 million. So we will get something like this. So we have used estimation. So for $350 million, we are getting around 59 5 $350 million, we are getting around 590 $599 million. So even the same thing we can do uh, the same thing budget. So revenue estimate is regression. So we are using this model as of now. Using old intercept and the coefficient. So here we are plotting. So we are rounding off around. So here what we are doing, we are rounding off that number revenue estimate. So it's like $650 million. Like, so here we have used this one like how much decimals it need to give. So it should be only one decimal. So this is how we have estimated. So again, we are using the linear regression formula only, like theta plus theta naught plus theta 1 into budget. So if we have multiple factors, for example, there is another factor like production costs uh, and unclaimed, I meant to say, there can be multiple costs, right? The food budget. So as of now, this is only, for example, production budget. But in movie, there can be multiple budgets like hero. For example, hero remuneration budget. So we can divide our budget into different variables, and even we can predict more revenue estimate depending on our data. So again, so whatever we build, so it again depends on all the data we are having. So we need to clean the data and we need to estimate properly, and we need to get our efficiency like explanatory variables correctly to predict uh, what need to be predicted. So here we are using revenue only for the budget, but depending on different models for our stock price prediction, we can have multiple factors like, for example, for stock price, it can be their results day, or it can be a budget day. It can be different factors and different things like, and depending on previous year's data. So all that data, it should be properly managed to make a prediction. So, and this is linear regression is very simple model. It can have negative outcomes also. As of now, we already seen for the above, because the intercept is going into negative, which is not correct estimation. So that also we need to handle going forward in different kind of models we have. That is about Scikit-learn. I think, yeah. So this very simple thing what we have done, but you can just go to Kaggle and you can just find out multiple things available. If you want to learn about linear regression, even if you just go to this also, the main Scikit-learn page also, you will be getting to know. So again, I am saying the mathematics is very important to learn machine learning models. So you don't need to uh, sit and do the mathematics, but you need to know how exactly what is intercept, what is coefficient, how we are calculating them, and how to implement that and how to get that values using our libraries. Yeah. Okay. That's it for today. Thank you.